All right, welcome back to Educator.com series on Java. In this lesson, lesson 2, we're going to work a little bit more with Java. First of all, we'll take a brief history of Java and see how it all developed. Java's been around for quite a while in terms of modern computer programming languages, and Java was originally developed starting around 1990 by Sun Microsystems in the California Bay Area. And it took a while before it was developed and fully ready to be released, and they knew exactly what they were going to do with it. So the development of Java's programming language and the development and popularity of the internet really sort of go hand in hand. Originally, Java was designed to simplify and enhance C++. Programmers at Sun were increasingly frustrated with C++'s syntax. It was quite lengthy. They wanted to simplify it and make it easier to type, not so much hard coding. And they were finding things that they couldn't do in C++ that needed to be done, especially for smaller devices, web pages, and so forth. The person that's mainly considered the author and originator of Java itself is James Gosling, a computer science PhD that was working for Sun at the time. He originally called the program Oak, based on an oak tree that he saw outside of his office every day. And when they looked into copywriting that, they realized that there was another software out there that owned the copyright for calling it Oak. So they had to figure out a new name. And so one of the things that programmers always like to say that their programming language is capable of is robust programming, and meaning that it can be dynamic, it can be versatile, it can do a lot of different things that other programming languages can't. And so they said, well, what's robust? Coffee's robust. Let's call it Java. And so the name was available. They called the programming language Java. And they first released it to the public around 1994-95. The original downloadable version was available in late 94. And then the full release in other media formats came in 1995. A very modern version is 6.21. That version was 1.0. 6.21 was released on July 7th, 2010. And that's a really modern version. You can see that there's been 6 major re-releases since that first original. All right, if you are going to use Java as a programming language, there are several things that you have to do to set your system, to set your computer up so that it's ready to program in Java and then ready to run the Java programs. Some of these things include downloading the JRE, the Java Runtime Environment. Now, most of the time your computer probably is already going to have this because if you are browsing the web, you are probably running Java programs, Java-enabled websites, and so the JRE is probably already there. But maybe it's a very new computer, maybe it's a computer that you just installed the operating system on, in which case it might not be there. Most of these things that we're talking about downloading are available for free download at sunmicrosystems.com/Java or just java.com. You should have no problem finding these things and downloading them and then installing them. Follow the instructions to install, and then you can start programming in Java on your own system. Some other things that you want to make sure that you have is the Java Development Kit. This enables programmers to develop and write in Java. And you also need a text editor. And if you've got a Windows system, Microsoft Notepad is fine. If you want to download from Sun Microsystems JEdit, which is specifically built for editing Java in a text editor, and on an Apple system, we are using the text editor Simultron here, which you'll be seeing today and throughout these lessons. You can also, if you want a full-blown integrated development environment, you can download and install the NetBeans environment. We're going to take a look at that again today. That's optional, however. You don't need an IDE to run a Java program. All you really need is a command prompt. But some programmers like IDEs because they have shortcuts. They are a little more easier to use in a graphic user interface system like Windows, and you don't have to end up doing as much typing. But an IDE is optional. If you download any of these requirements and you do some of the things that we're going to show you here, and you get an error that says something like the path environment variable is not present or it can't find it, or any error that you get that says anything about the path environment variable, what you need to do is alter or modify or verify what systems will call the path environment variable. What this does is it creates a link between the development kit and where that is housed and where that is stored on your hard drive and where all the files that you create are stored. So sometimes if it can't find that path, that class path, or that file path, it will give you this error. And for information on this, just search on these words at the Java site, java.com, path environment variable, and you'll find an instructional tutorial that shows you how to set that variable and how to verify that that variable is correct. All right, as we start to program in Java, we're going to be following the very common two-step process of creating a Java source file. And these files that we create in the text editor, these commands will be readable. They'll use command statements that we can recognize and that we know. And these files that we create in the text editor will not have a .txt extension, which these text editors might want to create by default. They will not have a .doc extension, as if we were creating them in Microsoft Word. They will have, and make sure if you need to, create and save these files so that they have a .java extension. It's still a text editor type file, but then when we compile the program and then run it, then it recognizes the classes that we have created within that text file. It recognizes it as a Java file. So that's the first step. We're going to create a text files with a .java extension, and then we are going to use that source file to compile the code. And when you compile source code, it converts it into bytecode, which is similar to binary. That way the computer can run it. The computer and the system recognizes it, although if you try to open up that file, it's going to look like gibberish to us because we as humans can't read that type of class file. And that Java class file is going to have a .class extension, and that's the one that the computer runs and recognizes when we actually run the program. We'll see these in the folder as we create them today. All right, when we create a Java application, there are two main ways to do this. As we were talking about, you can use the text editor and the command prompt, Windows command prompt, or the terminal command prompt on an Apple Mac system. Or you can use an IDE such as NetBeans. We're going to take a look at how to do both today once we get to our last program example. Otherwise, most of the time we're going to be doing these and creating these, or at least running these in the text editor and the command prompt. There are other IDEs out there that are Java compatible, not just NetBeans. Another popular one is Eclipse, which is free to download and install at eclipse.com. And through Sun Microsystems Java websites, you can also download and install what they call Swing, which is more of a graphic user interface, or a GUI, that enables programmers to be able to drag and drop and do other things in a graphic user interface system like Windows. Makes it easier. Right for now, we're just going to be sticking with NetBeans and using the command prompt. Now, at the top of some of these programs that we're going to look at today, we are going to see some classes that are imported. What this means is that there are some classes or programs that are utilities that are used very frequently. So they're built in, predefined, pre-written, and all you have to do is identify and call them at the top of your program. So we're going to declare them at the beginning of our program, and a good example of this, what we're going to be using today, is the scanner class. The scanner class enables the program to read user input, so it provides interactivity. So as you run the program, the user can input data, the computer can then scan that input, whatever you type, whatever the user types, and then use that information as it runs the program to spit it back out at the user in a print line, to do calculations, to do text editing, whatever the program is designed to do. The sample syntax of a predefined imported class would be something like the command that we're going to see, import java.util.scanner. And then the closing semicolon. And that will make available the scanner class for the duration of that program so that if we want the user to enter data, it's possible. We're going to be looking at some arithmetic and some math as we go here, and it's important to realize the differences between arithmetic rules of precedence, especially when we are comparing standard algebra rules of precedence that we might have learned in math class, as opposed to what will happen in Java here. You might remember the acronym PEMDAS from algebra class, or from really just basic arithmetic math class. And that acronym PEMDAS stands for parentheses, exponents, multiplication, division, addition, and then subtraction. In other words, when you see a long or complicated mathematical expression, that's the order that you as a mathematician should follow to solve that equation. Anything that you see in parentheses, calculate first, then resolve any exponents, and then take care of multiplication first, then division, then addition, and then subtraction in that order. Now in Java, as with most programming languages, it's a little bit different. You might think of this as PMDRAS for Java, which stands for parentheses. Everything in parentheses is still done first. Then it gets a little bit different. Then on the next level, second level, we have multiplication, division, and the remainder, the modulus operator, which usually is seen as the percent sign. In regular algebra, we've got plus, minus, we have our division symbol, and we have our letter X for the mathematical operator for multiplication. In most computer languages, spreadsheets, databases, plus and minus are the same symbols, but then we are going to mainly use the asterisk for multiplication and the slash for division. And then if you want to just manipulate or identify what's left after a division, we use the modulus, which is sometimes they just call it mod, and that is used by and identified by the percentage sign. Now what happens here on the second level of rules of precedence is that any multiplication, division, or remainder modulus operators are resolved first. There is no specific order. It will not do multiplication first or division second. It will do whatever is left to right. So in your expression, if you have multiplication after a division, it's still going to do that division first because it is going to move from left to right across your mathematical expression. Then, after the second level, it will move on to addition and subtraction and do that last, the same way. If subtraction is leftmost, it'll do the subtraction first. It won't automatically do addition first like it will here with standard algebra. In Java, exponents are not handled by standard mathematical symbols like we have in arithmetic or algebra. We might say 10 to the 8th power. In Java, we need to solve exponents with a separate method, which is math.power, in other words, mathematics and power. And we'll look at that as we get into more complicated math in later lessons. All right, so today we're going to look at 4 more program examples. We're going to see a program that can handle geometry with a circle and calculate diameter. If you give it a radius, it'll calculate diameter, circumference, and area. And then we're going to take a look at how we can use this text string data type to search through text string and locate things. And then we can also do a find and replace within that text string. Then we're going to take a look at a very neat program which uses a calendar function to not only recognize the date, but also manipulate that date and recalculate a new date. All right, so let's take a look at some of these examples. First of all, we're going to take a look at the text of our circle program, and what this in the Simultron text editor here will do is this program will calculate the diameter, area, and circumference of a circle if we give the program a radius. Notice the syntax up front here. We say that we want to import the java.utility.util.scanner, and so that is the imported class that we want to use throughout the program, so that's done right up front. Then we identify our public class. We're going to call this circle. Then we have our all-important required public static void main statement to identify the arguments of our main class. Then we get into the specifics of this program. The scanner class uses the input statement to get us a system in so that the user can enter data. Then we identify the variable radius. Then we are going to prompt the user to enter a radius with our system.out.print statement. All right, so that'll prompt the user, and then whatever the user enters at that prompt will be identified as the variable radius. So whatever number. Then based on that input, whatever number, whether it's a single-digit number, double-digit number, what have you, the system will then use that number to calculate certain things. And it's going to do this with system out print F statement. So it's going to be formatted text, in other words, properly spaced text in this example. So it's going to give the user the diameter, and the diameter is going to be based on this mathematical expression here, 2 times radius, or 2r, if we remember our geometry. Then it goes down to calculate the area of the circle, and here it is going to use the math.pi method, and math.pi will use the number pi, and it will multiply that by the radius, and then it's going to multiply that by the radius again. In other words, 2 pi r. It's going to square the radius, multiply the radius by itself, and then multiply it by pi. And that will give us the area of the circle. And then for the circumference, it will use 2 pi r, as we see in this statement, 2 times math.pi times the radius, and that will give us the circumference of the circle. Then at the end of the program, we've got our end braces, end curly Q brackets to end the main class and to end the circle class. All right, let's see if we can run this program in the DOS prompt. All right, so here we've got our terminal prompt. In a Windows system, it would be called the DOS prompt. On a Mac system, you use terminal. And when we identify this program, the first thing that we're going to need to do is compile the code. So we are going to, now that Java file is saved in our folder, in our Java folder on our hard drive. If I bring that folder up, you can see that the circle.java file is located there. When I go to my command prompt, and we want to say javac, in other words, Java compile, space, circle.java. Remember that when you're compiling code, you always have to make sure that the extension is included. Otherwise, it'll give you an error. So we say that we want to compile the Java program or the Java text file, circle.java. When I hit enter, it compiles the code. It returns me the command prompt indicating that the compile has been completed successfully. And now, when I bring back my window, you can see that the circle.java file is still there, but also the circle.class file is still there. So that's what's happening when we compile the code. It converts that text file, .java, to a .class file. Now that class file can actually be run here at the command prompt. All right, now if I want to run that program, we say we want to run it in Java, so we say Java circle, and when you run the program, you do not need to use the full file extension. We just say Java space circle, and when I run it, it prompts us, enter a radius. All right, I'm going to enter 3 and hit enter. All right, it runs successfully. It gives us the diameter of the circle, 6, so that's twice the radius. It gives us the area, 28.27 some odd units, and the circumference, 18.84 some odd units, and the program is run successfully. Let's try this one more time. If I say Java circle and hit enter, prompts us for the radius. Let's test this. I just want to enter a radius of 1 unit. Hit enter. Diameter is 2, twice the radius. The area is pi itself, 3.141593, so we know that it's doing successfully. The circumference is 2 pi r. 6.28 in some odd units. So we have been successful with our compilation and running the program. It handles the input. It gives us back the information that we were expecting. All right, let's go to our second example here. In this program, what this program is going to do is not calculate our diameter and area. It is going to search through a string. Now that's just in comment text. So whenever you see anything behind, remember, behind the double slash, that is comment text, and the program will just ignore it. It's a good way to leave notes for yourself, leave notes for fellow programmers, or if you're trying to explain something to students, you can leave explanations and the program will ignore it. All right, so this is going to be our public class search. This is a simpler program, so we're not importing any pre-built scanner classes or import utilities. We have our public static void main statement. Then we say search the string ABCDE, a simple text string. We identify index as a variable, an integer variable, and we start that as 0. So strings are always going to start with 0. So A is 0, B is 1, C is 3, and so forth. Let's say that we want to start with searching through that string for the character A, which I've just entered there. I'm going to save that, and then we are going to show the user then that index. So it's not going to return the text itself, it's going to return the index of the text. In other words, where in the string, what position in the string did it find? If it did find that character, what position within the string did it find that? If we do this successfully, it should be position 0 because it's the first character. All right, let's see how this runs in the command prompt. All right, here, if we want to start again with a clear screen, we just use the clear command. And then we are going to compile our code. This program is Java compile, and we are calling this search.java. It compiles the code, and now let's try running it. We say Java search, and it returns a 0. Why? Because we said search for A within that string, A, B, C, D, E. A was in the first position, and it returns us a 0. Let's try a little bit of a variation on this. We go back to our code, our source file. Now let's change that back to C. Let's save it. Let's go back to our command prompt. Let's compile it again. Remember, every time you change the program, you got to recompile it so that it is ready to run again. So we say Java C, search.java. It compiles. Now let's run it. Java space search. And now it returns a 2 instead of a 0. Why? A, B, C, D, E, 0, 1, 2. C is in the third position, which is actually digitally identified as the index as the second position, or number 2, not the second position, it's the third position, but it goes 0, 1, 2, and so that's why it's giving us back a 2. All right, so the program is running successfully. Let's go to our third example here. In this one, we are going to print text, and let's change our comment. And what this program is going to do is replace certain text characters within a string. All right, here we have the public class called replace, our public static void main statement, and now we identify the string as welcome to educator.com. All right, within that string now, we are going to use the text.replace method, and we're just going to say search for all the spaces, in other words, in single quotes, and replace them with a dash. So even though we have not entered dashes in our text string to begin with, that string we want to get modified so that dashes get entered when we run the program. Then we want the program to print that new text string to see so that we can verify that the dashes have been added. So let's see this program in action. All right, when we run and compile this, first let's compile that code. So we say Java C space, and we're calling this program replace.java. It runs and compiles, and then we say we want to run that program, Java replace enter. All right, notice what's happened. In the string itself, remember, we did not enter right here, we did not enter dashes. When we see the output of this program, we see that the dashes have been added. So what the method has done is it has replaced those spaces with the dashes, and it changes the output. All right, now let's look at our last example for lesson 2. And in this one, we are going to use some calendar functions. First of all, because we're going to require user input, we are importing our Java utility.calendar. And we're also, actually, in this one, it's not getting input from the user, it's getting input from the system. So that's why we're not using the scanner class, we're using the calendar class. So it's not input user, it is system input. We call this class calendar. We have our public static void statement. Then we set up a variable, calendar now, and we're going to get an instance from the system of a date. We are going to prompt the user, and that it's not going to be a prompt user, it's going to be an information that's going back to the user that says what today's date is, and that's going to give them the month, it's going to give them the date, and give them the year. Then what we want to have happen is we want to add one day to that today's date. That's going to use the function now.add, and calendar date is going to get added 1 to it. So whatever today's date is, we'll add 1 day to it, and then it's going to display in the next system out statement what tomorrow's date will be, because we've added 1 day to it. And here it's going to use the function, and it is going to return tomorrow's date to the user. All right, let's see what this looks like in the command prompt. All right, now, looking at our files in our folder, you can see that the previous files that we've used, Circle has a Java and a class file, Replace has a Java and a class file, same thing with Search. Notice that because we have not compiled calendar, we only have calendar.java. Let's try to compile this. We say Java C calendar.java. It compiles successfully. When we look at the folder, now we've got our calendar.class file, so we're ready to go with running. I want to say now Java space calendar, run it, and it gives us today's date. Then it gives us tomorrow's date because it added one day to today's date. All right, so we were successful with running all of these programs through our command prompt. Now let's do one more thing. This last calendar program, let's see if we can build this in the NetBeans IDE and see how it runs there. All right, first of all, I'm just going to copy my program text from my text editor, and then eventually we're going to paste that into the file that gets created in NetBeans. So I'm going to do a Command A here, and then a copy, Apple C or Control C. We will minimize this. Then we will go to our NetBeans window. Here I'm going to create a new project. We want a Java application to be created. I'll click Next. We're going to call this Calendar for the main class and the project name. We give it a second, and then it creates the project. Once the project gets created in NetBeans, you can see the main.java tab come up along with identifying the public class and the packages that NetBeans uses to assist us with creating and running the programs. Now we're going to create our source file within this project in NetBeans. So we say new file. We say that we want to create a Java and a Java class. We're going to call this class calendar. It creates the new .java file. Here I'm going to select all and delete the information there because we're going to paste it in from our original source file that we had in our text editor. I'm going to do a paste, Command V. All right, it pastes the same text in there, and now we're ready to compile it. When we do a compilation in NetBeans, we go to our Build button, Build Main Project, the hammer symbol. I click that. In our output window, it tells us that our build has been successful. All right, now we got to do one more thing before we run it. We have to right-click on our project tab over to the left, go down to Properties, and go to the Run category, and ensure that the main class has been identified. Sometimes you need to do this more than once if you get an error. If I identify the main class as calendar, we select that, we click OK. All right, now it's identified the main class. Now let's try run the program. All right, we get the output successful. Down in the output window, it says today's date is August 30th, 2010. Tomorrow's date, it adds 1, will be 8/31/2010. So we've just showed you how to do both. We've run the program from the command prompt, compiled it and run it from the command prompt, and we've compiled it and run it in the NetBeans IDE environment. All right, that's it for Lesson 2, and thank you for watching educator.com.